everyone. We are discussing resolving a vector into its components. Let's see that part again, the whole process. We're now be heading resolving a vector into its components. And so far I have given you this much information. This is the axis system. We have a vector. Let's say this is F vector. We have done these things in the last class, but again, a fast revision. This is F vector. This F vector is making an angle of theta to the horizontal axis, which is the x-axis. Our aim is to represent F into its components. Now, what are components? Why do we resolve a vector into its components? We will understand these things in today's lecture, but first focus on this analysis. What we did, we dropped a perpendicular on the horizontal axis, and then we define a vector in this form and another vector in this form. This, and the black one. Two blue and the black. This vector is pointing along the x-axis, and we gave it a name of fx vector. This vector is parallel to the y-axis, and we'll call it fy. fx, fy, and f. And now the whole setup is nothing but triangle law of vector addition. Triangle law of vector addition says what? On the head of fx is the tail of fy. And then finally we join tail of first with the head of last, giving us f. That is, f is nothing but fx plus fy. Our main vector is what? F vector, and this f vector is what? Fx plus fy. Fx and fy, these are called components of vector f. And these components, fx and fy, they are always perpendicular to each other. They are mutually perpendicular vectors, fx and fy. This is something which we have done in the last class, and also the next step. In the next step, we will measure length of fx, length of fy in terms of length of this line and the angle theta. We know that length in vectors is nothing but magnitude. So what we had done in the last class, we drew this length This length is f. I have removed the arrow sign. I have removed the arrow, and this arrow. I am interested only in the magnitude part and these two lengths. This is fx. This is fy. This length is f and this angle was theta. And then simple geometry, fx divided by f is coming cos of theta. Base upon hypotenuse is what? Cos. This gives us fx as f multiplied by cos of theta. Similarly, this fy upon f perpendicular upon hypotenuse is what? Sin theta. That gives us fy as f sin theta, which means we can find magnitude of this vector in terms of f and theta. Similarly, magnitude of this vector in terms of magnitude of this vector and theta. Now, how does it help us? This whole process. Now, look at this part over here. Suppose we have been given that, concentrate here, we have been given that there is a force F which makes an angle of 45 degrees with the horizontal axis. This horizontal axis is for us x-axis. We are being given what? We are being given this vector f, which makes an angle of 45 degrees from the x-axis. And let's say this x-axis is, it represents east. This is east. This is x-axis, which is east. Then y-axis, it automatically becomes what? North. This arrow, we were told its magnitude is 10 newtons. What we have been given? We have been given F, which is also written like this. That is 10 newton. A force of this much magnitude. If I ask you how do you write F, then you write F in this form. A magnitude of 10 newtons. This format needs both magnitude as well as direction. So this is the magnitude, which is 10 newton. What is the direction? Something exactly between north and east. Remember, exactly between north and east. Direction is called northeast. This is called force, newtons. This is called direction, northeast. Now, this 10 newton northeast, we want to resolve this vector into its components, and for that we will say that this F is equivalent to this, which is Fx, this, which is Fy. Now pay attention to each and everything. Just look at board. This 10 newton, which is northeast, I will simply say that this is Fx plus Fy. Fx plus Fy coming from this. Fx plus Fy like this. What is Fx? This Fx vector, its magnitude is what? F cos theta. F cos theta. What is F? This much length. What is this much length? 10 newtons. What is theta? 45. That means for that given setup, your Fx is 10 multiplied by cos of 45 degrees. Everybody knows what cos 45 is. We'll write it 10 by root 2. Similarly, 10 sine 45, which becomes 10 by root 2. What is sine 45 degrees? 1 upon root 2. This gives us 10 by root 2. Now, what is Fx? Magnitude 10 by root 2 newtons. What is Fy? Magnitude 10 by root 2 newtons. But now look here. What is Fx vector? What is Fx vector? A vector has magnitude as well as direction. What is the magnitude? 10 by root 2. I'm just not using unit part Newton for the time being so that we can avoid the confusion between north and Newton. This is the magnitude. What is the direction of Fx? What is the direction of Fx? Direction of Fx is what? East only. And therefore write 10 root 2 comma east plus what is Fy? Fy, its magnitude is what? 10 by root 2. Its magnitude is what? 10 by root 2. And what is the direction of Fy? What is this direction? This direction is what? North. This 10 by root 2, its direction is coming direction of this Fy is coming 10 by root 2 north. This is north. We'll solve different examples and you will get a hold on all these things. But right now, 10 newtons northeast. If they ask you that, resolve 10 newtons northeast into its components, then the answer is what? 10 newton northeast is 10 by root 2 east plus 10 by root 2 north. Why do we resolve it? We'll understand that in just a while. But right now, note down this example. And if you miss this part, then also note down this thing. If you do not feel comfortable with this, just don't worry. In just few minutes, you will find that these things are quite easy. For the time being, note down everything. Don't forget to use arrowheads, proper arrowheads. Note down this. By the way, those of you who have understood the whole thing in first attempt, if you have understood everything in the first attempt, just 10 by root 2 east plus 10 by root 2 north. If you understand the whole part, then write down yes in the comment box. If you do not, there is no need to write yes. We'll again handle some examples and you will see that these things are quite easy. Look here. A much better way of understanding this is with the help of displacement. Suppose we have been given a displacement vector d. We have a displacement of 20 root 2 meters northwest. Displacement of 20 root 2 meters northwest. Northwest. I'm giving you 1 minute's time. Let's see first, without my help, how many of you can resolve this displacement into its components, mutually perpendicular components. Write down the question. Resolve a displacement of 20 root 2 meters northwest. Resolve a displacement of 20 root 2 meters northwest into its components. We need to find what components of 20 root 2 meters northwest. This will help you in understanding the meaning of components. You can easily visualize it. But first, few elementary things, and many a times I have found that people commit these silly mistakes. This is north, this is west, east, and south. When I say northwest, some of you draw northwest like this. You think that this is the northwest vector or direction. No, it is not. While drawing a vector, remember these simple steps. While drawing a vector, the person who is drawing a vector is standing over here, which is called origin, position of observer. You are standing at this point. Somebody is standing at this point. If you ask him, move northwest, then he will look at the north direction, west direction, and then is going to move exactly in the middle, like this. This angle is what? 45. And this direction is called northwest. This, remember, is not northwest. Why? Because the person who is going to draw this vector is standing over here at the origin. As a side note, you will mention it. And now, look here. So, we have been given a compass like this. This is north, this is west, and then 20 root 2 northwest. We will draw an arrow. We'll draw an arrow which makes an angle of 45 degrees, and length of this arrow is 20 root 2. This length is 20 root 2. Angle is what? 45 degrees. For us, it represents D vector. An arrow of length 20 root 2 meters at an angle of 45 degrees exactly between north and west is D. Now, what does it mean? It means this. Let's say this is the initial point, I for initial. This is the final point. You are given a command that move 20 root 2 northwest. You started from this position and ultimately you arrive at this position. So when I say that, resolve this vector into its components, it means you could have reached the same position had you followed this path. First, move west. I hope you can see it. First, move west. We'll call it we'll call it dx vector. This is dx vector. And then move like this. We'll call it dy vector. So if somebody moves along the x-axis and then he moves along the y-axis, shown in blue color, then also he will arrive at the same point, starting from the same position. That is, it means what? If you follow the black path or you follow the blue path, your destination is what? Same. And therefore, this D is same as dx plus dy. Either give the command D in this form or break the command into two mutually perpendicular directions, dx and dy. Now, this dx, I'm using black color so that you can see it properly. Dx has some magnitude as well as direction. Direction, everybody can see, is what? West. Similarly, dy has some magnitude and the direction. Direction, everybody can see, is what? North. West, north. We only need what? Magnitudes. What do you mean by magnitudes? We can do it directly, we'll do that also, but just so that you get a command over the whole thing. We have a triangle like this. This length is 20 root 2. We have two arms shown in blue. This much angle is 45 degrees. If this is 45, the whole length is 20 root 2, this length and this length. If I say this length is L, then this length is also what? L. If this length is L, this length is also what? L. Simple analysis, if we don't go for resolving the way we did cos theta and sin theta. Just because this angle is 45, it tells you that this and this, they both are what? Same. This L and this L, they are what? Magnitudes. L, L. This is L, this is L. You could have used a simple argument like this. Root over L square plus L square. L square plus L square, simple Pythagoras. L square plus L square is giving you what? 20 root 2. Which is L root 2. I hope you understand this much. 2L square, take the root, it becomes L root 2. So your 20 root 2 is what? L root 2. Root 2 cancel. Your L is coming what? 20. 20 meters. So L is coming 20 meters. That means you got this L, you got this L as what? 20 meters. And finally you can put it over here. What is dx? Dx is 20 meters. Dx is 20 meters west. Followed by dy, which is L, 20 meters. The direction is what? North. 20 meters. Direction is what? North. This is resolving a vector into its components. Now, instead of making a triangle again and again and doing this type of calculation, what I have told you is this. I have told you that dx, we call dx the base component. Base means the one which is attached with the angle between the hypotenuse and base. So what is length of this? Length of the main vector into cos of theta, which is 45. Length of the main vector into cos of 45. What is cos of 45? 1 by root 2. Root 2 and root 2 gone. you get your dx as what? 20. You can do this whole thing this fast. Similarly, if somebody needs dy, then dy is opposite to the angle, and therefore it represents what? Perpendicular. Perpendicular means length of the main vector 20 root 2 multiplied by sine 45. Sine 45 is also what? 1 by root 2. That gives us 20 meters directly. You don't have to make this triangle again and again and use this analysis. Simply do what? What is this length? This multiplied by cos. What is this length? This multiplied by sine. And then the directions. Put down everything and then we'll take the next example. So those who did not answer it or answered it wrong, if they understand it now, then write down yes in the comment box. If you could not answer it or your answer was wrong, if you understand it now, if you do not, simply say no. Look here. We have been given our displacement vector, a displacement vector of 20 meters, and this angle is what? 60 degrees. 60. First, tell me this. Can I say that D is 20 meters northeast? Yes or no? What do you think? Write down in the comment box. If a vector is given in this form, then can I write D vector like this, 20 meters northeast? Yes or no? Good. We cannot say this is northeast because Northeast means exactly 45 degrees. So write down this and then make a cross. You cannot write it like northeast. How do you define this direction? Understand that. First, try to understand it and then you will write the whole thing. Northeast means exactly between north and east, that is 45 degrees. But if you have something like 60 degrees, then we say that at an angle of 60 degrees from east, at an angle of 60 degrees from east. Well, that is not sufficient. You can have an angle of 60 degrees from the east towards this side also. What is special about this side? What is special about this side? We say that this particular angle which you see 60 degrees and which we have taken from the east direction, from the east, is towards north. We say that direction is it's 20 meters at 60 degrees from east to north. 60 degrees from east to north. You can also write it in this form. This is 60, then this angle is what? 30 degrees. Total is what? 90. The same direction, same command can also be represented like this. 20 meters at an angle of 30 degrees, but this 30 degrees is from north towards east, from north to east. If it's exactly 45, write down northeast. Otherwise, you provide your directions in this form. 60 degrees from towards, 30 degrees from. Now, go down this much and then the question is, resolve the vector into its components. Go down this much, resolve it into its components. How do you resolve it? The process is very fast. Draw this. Draw this. This is your dx. This is your dy. Your d vector is dx plus dy. This is always dx plus dy. We need dx, its magnitude. We know the direction of dx. What is the direction of dx? East. We just need its magnitude plus dy. dy. We know the direction. Direction is what? North. We just need to write the magnitude. How do you write magnitude? Again, what is this length? 20. Main vector is what? 20. This is what? Base component. What is base component? Cos. So, what is dx? If I ask you what is dx, I'm not using arrowhead. Now I'm interested in the length, magnitude. Simply 20 cos 60. 20 cos of 60. What is cos 60? 1 by 2, 10 meters. dx is coming 10 meters. Now we need dy. What is dy? dy is the perpendicular component. It's the perpendicular component. This much 20 multiplied by sine. 20 sine 60. What is sine 60? Root 3 by 2. 10 root 3 meters. Put it over here. 10 root 3 meters. So, a displacement of 20 at an angle of 60 degrees from east towards north is same as first move 10 meters east, then move 10 root 3 meters due north. These are called perpendicular components, mutually perpendicular components of the main vector. Note down this much. Only one person answered the whole thing correctly. The rest of you, if you understand it, then write down yes. And I'm again telling you, if you do not understand it, simply say no. I should know what your problem is, where are you confused and all. And that way I can help you. There is no issue if you write, somebody is asking that what if you move north first and then you move east? No issue. You can move north first and then you can move east. There is no issue. 5 plus 3 is same as 3 plus 5. It doesn't matter. What is the doubt? Last word out. You can switch on the mic.
Sir, it may be kind of stupid, but you said that if you move 10 to 3 meters north, after moving 10 meters east, you would reach the definite position. But sir, how can one decide like root 3 is irrational, it is of indefinite value? So how can we reach the exact position with it?
See, root 3 is irrational. That is because of your measurement technique. You have defined 1, you have defined the length of 1, 2, and you say that these lengths are what? Unique lengths. These unique lengths are what? Rational lengths. But what makes you think that 1 is rational? Since 1 is rational, root 3 is irrational. If you say that root 3 is rational, then 1 becomes irrational. That is maths. We're not talking about physics. Basically, the question which you're asking is related to maths. If somebody says that this much length is rational, if they say that this length is also rational, then this length becomes what? Irrational. Try to understand it again. If I say this is L, then this length is L root 2, which is an irrational length. But what is the assumption? This length is rational. What if I make a right angle triangle in which this is the hypotenuse and these two are what? The rational parts. This thing will become what? Irrational in itself. So we are not interested basically in the argument about rational and irrational. What we are saying is this: if you move 10 meters, there is no way you can even move exactly 10 meters. If somebody says that move exactly 10, then even this is not possible for us. When you move 10 meters, maybe you're moving like this, 10.0000000000001, or you maybe move like this, 9.999999999. There is no guarantee that you exactly moved 10 meters. There will be always an error part present, and therefore we are not interested in root 3 being rational or irrational. We'll say that root 3 is a number which for us is as good as 1.732. That's all. For us, root 3 is what? 1.732. We'll say that this much is good for us. Write down next question. Resolve a displacement of resolve a displacement of 100 meters. Resolve a displacement of 100 meters at an angle of 37 degrees. Spatial angle. 100 meters at 37 degrees from west to south. 100 meters at an angle of 37 degrees from west to south. Regarding 37, you will remember this information. I hope everybody has seen a triangle like this. This length is 3, this length is 4, and this length is 5. A right angle triangle. Lengths are not exactly up to the scale. This is 3 and this is 4. I simply drawn the figure, a right angle triangle. A right angle triangle like this is something which everybody has seen. 3 square plus 4 square is what? 5 square. In this triangle, this angle is 37 degrees. Remember this. Which means what? Whenever I say 37 from now onwards, if I say 37, then you will need sine 37 and cos 37. What is sine 37? Sine 37 is what? 4 by 5. Standard value. You're supposed to remember these values just the way you remember sine 30, sine 45, sine 60. You'll also remember sine 37. Similarly, cos of 37. What is cos of 37? Cos 37 means base. Just wait, just hold on. If this is 37, I hope you can see this branch cannot be 4. If this is 37, this branch cannot be 4. 4 means this branch cannot be greater than this branch. If this is 4, this is 3, then the angle should be more than 45. Just a small correction. The small correction is this. If this is 37, then your base is what? 4, and this perpendicular is 3. Now everything is correct. Even the figure is looking good lengthwise. Somewhat lesser length as compared to this. What is sine 37? 3 by 5. What is cos 37? 4 by 5. Remember these standard values of sine and cos. At the same time, look again. If this is 37, then this angle is what? 53 degrees. Sum of all three should be what? 180. I hope this angle is visible to you. This is 37, this is 90. The angle in red is 53. I'll use the black marker. This sine 37. If I say what is sine of 53? What is sine of 53? Let's see if you are comfortable with sine and cos or not. This is 37, this is 53. In the comment box, write down the value of sine 53 fast. Let me see if you are comfortable with sine and cos or not. Do it fast. Good. When you are interested in 53, then what is sine? Perpendicular. What is perpendicular? The branch opposite to the angle. For 53, this 4 is the perpendicular, and therefore you will write 4 divided by 5. And similarly, cos of 53, if you write cos of this, then cos means base. For the angle 53, 3 is the base. 3 divided by 5. These are the standard values. Always remember these values. And as I told you, the branch opposite to 37 should be smaller than this branch, and therefore 3 and 4. If this is 53, then the branch opposite to 53 should be larger than the branch directly linked to the angle. And therefore these values. Now, you have your question. Write down the answer in the comment box. A displacement of 100 meters at an angle of 37 degrees from west to south, resolve it into proper components. Do it fast. Everybody should participate. It's not a difficult thing. Draw the figure. Use the concept of sine and cos, and it's something which is very easy. Draw the figure. We are interested in west and south. This is west, this is south. And remember, you are standing over here at the origin. The question says that move 100 meters at 37 degrees from west to south. From west to south. This angle is 37. This length is 100 meters. This is your D. Now, when you are being given something like this, 100 meters at an angle of 37 from west to south, and I ask you to resolve the whole thing, you will do what? You will move like this, draw the arrowhead, draw the arrowhead. Draw the arrowhead like this. We'll call it dx. We'll call it dy. Dx, dy. And this black one is your d. So your d is nothing but dx plus dy. Dx plus dy. And finally, what is dx? What is dx? 100 base component, base. And therefore 100 cos 37. 100 cos 37. What is cos 37? 4 by 5. Which becomes what? 524 80 meters. This dx is 80 meters. 80 meters. What is the direction? West. Plus dy. What is dy? dy is 100 perpendicular component sine 37. Sine 37 is 3 by 5. This is 100 into 3 by 5, which is coming 52360. You're moving 60 meters. And what is the direction? Direction is what? This. Look at the arrowhead. What is the arrowhead? Arrowhead means what? South. South. So a command like this 137 from west to south is equivalent to what? These two mutually perpendicular commands, and these two commands are called components of this vector. Put on this much. Everybody has answered correctly. Now just with the help of this same example, as I told you, this 100 meters 37 from west to south, they could have given you the whole command in this form also. 100 meters at an angle of 53 degrees. If this is 37, then this angle is what? 53. This is 37. This is 53 degrees. So instead of saying 37 from west. I can also give you at 53 from south towards west. From south to west. This is same as this. 100 meters, 37 from this side or 53 from this side. Now, I want you to resolve this using 53, and ultimately your answer should not change. Final part is what same, but this time you will not be using 37, you will be using 53, and you will draw a separate figure, don't do everything in the same figure. Take this command, which is same as this, and ultimately get this answer. Once you arrive at the same answer using 53, write down yes in the comment box. Once you arrive at the same answer, then only you will write yes in the comment box. Go down this. So you cannot write dx as 100 sine 37. You cannot write dx as 100 sine. Why? 37, if this is the angle, then the branch which is adjacent to the angle is what? Base. There are two arms. The shorter one is base, lengthier one is the hypotenuse. This 37, this dx, it is what? Base. And what is base? Base is what? Cos. Sine is used for perpendicular, and therefore dx is always cos 37. And to understand the difference of sine and cos, I have given you the second one. Try this one and you will understand the difference of sine and cos. Everybody give it a try, and once you arrive at the same answer, write down yes in the comment box. Look here. This is the vector. This time, this angle is 53. So what we are going to do is this. move first along the y-axis, and then move along the x-axis. Don't forget to put these arrowheads. The main vector D of 100 meters at an angle of 53 can be represented with the help of dy and dx. dy along the y-axis and dx. Still, this thing is what? dy plus dx. It doesn't change. On the head of y is the tail of x. This is what dy plus dx, which is same as dx plus dy. The only difference is this dx. Look at this dx. Instead of plotting dx, instead of plotting it here, we're plotting it at this position. Instead of plotting dy at this position, we're plotting it at this position. You just need to find dy and dx. But now, if this is 53, then I told you that the branch, the arm, which is connected to the angle, adjacent to the angle, is what? Base. And therefore, this dy, look carefully, total length 100, this is the angle 53, and the arm attached to 53 is base. What is base? Cos. So write cos of 53. Cos of 53. Similarly, dx is 100 sine 53. Dx for this triangle, this dx is opposite to the angle 53 and becomes what? Perpendicular. For perpendicular, we use what? Sine. Now, what value of cos 53? Cos of 53 is what? 3 by 5, making it what? 60. What is the value of sine 53? 4 by 5 makes it what? 80. Now, what is dy? 60. What is dy? dy is coming 60, 60. What is the direction of dy? What is the direction of dy? West. 60 meters west plus, what is dx? dx is 80. What is the direction of dx? What is the direction of dx? What is this direction? West. Sorry, this dy was not west. Dy was what? This is what? South. So this is south. And this is what? Is west. What is the final answer? 60 south, 80 west. 60 south, 80 west. You're getting what? Same answer. So it doesn't matter whether you take your angle from x-axis or you take your angle from y-axis. It doesn't matter, provided you choose correct values. Now, from now onwards, just to avoid confusion, we'll always prefer 37. This way we have to remember only one angle. Otherwise, people get confused between sine 37, sine 53 and all. So if they give you information in terms of 53, either you continue this way or you can simply convert that 53 into 37 using this figure. I hope you understand the whole analysis. Now note on a few questions for homework practice. You're supposed to resolve these vectors into their components. The first is a force of 50 newtons (37) from north to west. Force of 50 newtons is acting at an angle of 37 degrees from north to west. We'll draw a figure and its components. Second, V for velocity. Velocity is a vector. 20√2 meters per second southeast. 20√2 meters per second southeast. Third, the displacement of (80 meters) (37 degrees) from east to north. 80 meters, 37 degrees from east to north. These are 3 questions as homework. You will solve these things, take a snapshot and send the photograph over WhatsApp. Note down everything and then you can leave. Thank you very much.